Hello everyone, I'm Brice Dutheil and here's DuyHai Doan, and today we will present what we have learned when migrating billions of contacts from a SQL database to Cassandra. So a little word about myself. I'm a core Mockito developer and also happen to be a program at a Java track lead at the program committee of the DevOps conference. I work as an independent contractor at Orange Valley, which make a product called Libon. And here's DuyHai Doan.
Hello, so my name is DuyHai Doan. I'm working as a technical advocate for Datastax. And before that, I was working for Libon also, and I was involved in this migration project. So that's why I'm here to talk with Brice. And on my free time, I'm working on Achilles, which is an open source object mapper for Cassandra. Will you have time to talk about it later?
So what we are going to discuss today, it's about Libon first, because this is the product, and what brings us to migrate from a SQL database to Cassandra. We'll discuss about what we thought was good to migrate things. We'll have a look at the code, and especially we'll look at the data model. And I hope you can take away a few interesting things from what we have learned during this talk. So first, the Libon context. Libon is a messaging application. You can call people. You can have a feature, it features custom voicemails and greetings for your contacts. Of course, it's a messaging app, so you can send pictures to your friend and chat with them. And it has a basic contact matching. So that's the topic that interests us today. Sorry. If I am a Libon user and I have a friend that happens to have my number and this friend joins Libon, there will be a contact matching performed by the Libon application. And if I accept this contact, I will be connected to this guy. Libon grew over the year in terms of users, and we have already an experience with Cassandra, with events. I talk about messaging, and that's exactly where we have put Cassandra. It shows pretty good figures regarding the numbers. The latency of Cassandra is always sub-millisecond, which is very good. And our response time are under 10 milliseconds, which is very good for a mobile network. So, as I said, there's a growth of users. And with contacts, it's beginning to be a problem, because it's stored in a relational way. A user has about 300 contacts. And if you do the math, there will be like billions of contacts to handle in this relational database. So we are kind of uncomfortable with the future about this, the query time it takes for our application to work. And we had our problem already. So we went, like usual, to the relational database, indexes, partitioning, thanks to Oracle. We also reworked our data model. We have to tune our queries. We also increased the hardware, and we replaced mechanical disk with SSDs. We doubled the RAM. But, well, what about the future? Really. Relational databases, they have been there for a long time. They are robust. They are very convenient. They are flexible for the queries. If the business is changing, you just change the query, and it works. And we have kick-ass DBAs. But if we want to go further ahead and scale, we want to look for something else. So our next challenge is on Libon is under hardware failure. The more hardware you have, the more it can fail. Also, with the user growth, we want to have a predictable performance if we want to add nodes. We just have to be sure that the query will be done in the same time with the same latencies. And going worldwide is maybe a challenge for us. So Cassandra is again the choice we have made. That means that we have to think in a denormalized way. It means also that there's a mindset change. So we have to know how we access the data. The access pattern is very important. Are we ordering? Are we grouping? Is it time related? Does the data expire? It's important to know that. And if the data model is right, we expect to have a linear scaling, and so a consistent performance when the user is growing. So let's talk about the migration strategy.
So the objective of this migration strategy is to not to have any downtime, because we don't want to lose customers, okay, of course. We don't want to handle complex concurrency corner cases while migrating data. The ops ask us to make this process rollback capable. It means that we should be able to stop it at any time, to resume it, and to repeat the migration process. So the idea is to make a three phases migration. In the first phase, we are just writing contacts to both data store, Oracle and Cassandra. In the second phase, we are just migrating all contacts from Oracle to Cassandra. And of course, in the last phase, we are switching to Cassandra and deprecating the old SQL code. So let's see in detail phase one. Here, all the new contacts are created. We created them both in Cassandra and in Oracle. So we are using a sequence in Oracle to generate the contact ID as a long, okay? And for Cassandra, we generate time UID. And we added a new column in the Oracle table called contact UID, where we just store the contact ID generated for Cassandra. It means that if you have a contact in this table with a null contact UID columns, it means that this contact has been created before phase one, of course. So this is for phase one. And of course, when we are reading data, we still read from Oracle. So from the external client point of view, nothing has changed. No breaking change. For the second phase, on live production, we are launching the migration batch. The idea is to take a batch of users, and for each of them, just select all the contacts with null contact UID, meaning that they have been created before phase one, of course. And we put them into Cassandra with a special timestamp, which is in the past, now minus 1 week. Well, 1 week, 1 day, whatever, but in the past. Why do we do that? Because during the data migration, we may have concurrent write coming from the migration batch and updates coming from live production, of course, to the same contact. Let's take an example here. I have a contact with a name, Johnny, which has a typo. So the batch, the migration batch, is inserting this name with a timestamp in the past, okay? And at the same time, the user is updating this name because to fix the typo. So the update coming from live production, we save it with the current timestamp. Because we want that future read, we pick the most up-to-date value, of course. The idea to write to the past is that we want to give higher priority to live production updates. And with this strategy, well, we don't care about any concurrent update issue because we rely on last write wind from Cassandra. And of course, for the last phase of the migration, we are just deprecating the SQL code and switching completely to Cassandra.
So that's the migration strategy. Let's go to the code inventory. So as I said, it's written for a relational database in mind, and that means there's relations, hence joins, a lot of them. And of course, it's an ACID database, so we have transactions and Spring is used everywhere. So we have the nifty annotation add transactional everywhere. The thing is, we are working around a contact entity. It's leaking from the repositories to all the services that need to use it for things like, I don't know, whatever. And we rely on the magic of Hibernate. Hibernate is a really cool tool with many features like lazy loading, first level cache, and you have to tune it. It's really the rim of Wonderland there. Nice. But what are we going to do if we want to migrate to Cassandra? Shall we throw our existing code and everything and redo everything from scratch? Dangerous. Maybe it will take a year, maybe more, I don't know. So no. Actually, the team has invested a lot of time in code quality. We have more than 3,000 unit tests there. We have more than 600 integration tests. And the team is kind of TDD practitioner. I mean, every member is a TDD practitioner. And we care about code coverage and code quality everywhere. It's one of our most valuable assets. And with that, we'd like to leverage that asset to refactor the repositories without breaking anything else. So that slide depicts what we add. A contact entity used in a bunch of services. This contact entity has, as I said, several relations. The idea is to use an object that will act as a proxy. It's just to extend the contact entity for now. And this proxy will be projected into several denormalization that will matches our access patterns. Further on, we can refactor and remove things, but that's another story. Also, as we are refactoring the repositories, we don't use the DAO pattern anyway with Cassandra. We are thinking about CQRS, which means command, query, responsibility, segregation. That means that we have different needs for write and read. For example, for the reading strategy, there is multiple read repository, and we'd like to have to leverage Cassandra for direct sequential reads. We don't want any joins, I mean, on the application side. And each read should do like one select, which is very performant. For writing, repositories that writes take in charge several things, like propagating the writes to all denormalizations. If there is a TTLs, this repository will put the TTLs, and it uses the batch statement of SQL. Updates. Again, it's a different story, because this time we have the unfortunate read before writes. But that's okay in this case, because we know that we have very rare updates on the contacts anyway. So it's okay. And delete is again another story, because there is some involvement in the business rules there. But that's just the way we did the things. So the outcome of this is that we have refactored most of this in 5 months. And it was 2 men to do that. That took us a lot of iterations, thanks to the feedback loop of integration tests. We managed to keep the same functionality there. And also, very important, do performance benchmark. Irrelevant issues or invisible issues in a standard application, they become really visible under load. And that's we have at Libon. For example, take this Gatling output. If you don't use it, just try it. It's simple. There is this graph is just a part of the output. It plots the response times of our application over 2-hour runs with different percentiles. Really, it can help you to compare the old data, the old model with SQL and Cassandra. So it helped us to validate both the data model we did in Cassandra and our code, because this code will have an impact on Cassandra itself. And for that, we are almost ready to go live. Let's dive into the data model.
So we denormalize. Denormalization is good because it supports very fast reads, okay? One read pattern is at most one select. That's the idea. It is worthy when your business scenario is mostly read and very few updates. The bad thing with denormalization is sometimes if you need to update mutable data, and if you denormalize a lot, it can be a nightmare, okay? And we cannot change our existing API because we have already existing client using it, right? So we cannot break it. So we have to deal with it. The update path can be very, very error-prone. But since we have a lot of testing, unit tests, integration tests, we use them to fix many nasty bugs. So this is the data model in detail. You can see here some denormalized table. In fact, most of them are for searching. Search contact by identifier, by ID, of course, but also by first name and last name, and so on. We try to put the user ID as part of the partition key, yes, because we want to be able to scale out. If in the future, the number of users will increase a lot, well, we will just add new nodes into the cluster, and Cassandra will distribute evenly all those loads. Okay, that's the idea. For some tables, we also add the contact ID as part of partition key, because we want to leverage Bloom filter for very fast lookup. If the contact does not exist, well, the Bloom filter will give you true negative. You will never hit disk very fast. And if Bloom filter say yes, well, you will touch disk and touch only one file most of the time. We have some wide partition here, and to avoid being too wide, we use bucketing. So here is the contact by modification date. It is a queue-line pattern, and we all know that it's a bad pattern. The idea is to create buckets by months, monthly buckets. So we add the months component into the partition key, and instead of writing and deleting data, which is bad, we are just appending data to the partition, and when we reach the end of the month, we just switch partition. And of course, we are writing with TTL, so all data will be expired. So in a nutshell, we have 7 tables for denormalization. We have some normalized tables, but we don't care because they are very rarely accessed. And of course, read before write is mandatory because when you denormalize so much, you need to fetch all the partition key before updating data, of course. For example, to update contact by first name and last name, you need to have first name and last name because contact ID is not enough, of course. That's trade-off. Oh, some notes about the contact ID. As I said, the contact ID is coming from a sequence as a long, and for Cassandra, it's a time UUID. So how can we store both data types in Cassandra? Well, the easiest solution is to encode them as text, but we are wasting a lot of spaces. For a long, it is encoded as 8 bytes, but if we encode it as text, well, the byte count is the digit count. With UUID, it works. UUID is encoded using 16 bytes, but if we encode it as text, we have like 20 bytes overhead per contact UUID, times 7 denormalization, times billions of contacts. It will give us like 140 gigabytes of this space wasted, just because we are encoding in text, not even counting replication factor. So the idea is to use byte array, okay, to store all of them as byte array. And we are leveraging Achilles type transformer for automatic conversion. We'll see it in a few slides. And for production debugging, if we want to display the contact ID, we can use SQL native function, blob as begin or blobs as UID, to convert the data on the flight, to have something human readable. So Achilles is used everywhere at Libon. It is an advanced object mapper that offers lots of features, and especially it is very TDD friendly. And with Achilles, we use heavily dirty checking. So what is it and why it's so important? Let's take a contact. In a contact, we have 8 mutable fields, right? And we have 7 denormalization. It means that we can have like up to 56 update combination, not even counting multiple fields update. Now, we don't want to prepare manually, okay, all the prepare statements for all possible updates, because there are too many. We don't want to use plain text query at runtime because it has some performance penalty. So the idea is to use the for update API of Achilles. So how it works? You are calling for update, providing the entity class and the partition key. Achilles will create a proxy for you. There is no read before write. We don't read from Cassandra. And on this proxy, you can just call the setters to perform your update. It is completely type safe. And how does it work? Well, the proxy is just encapsulating an empty entity. And whenever you are calling a setter, Achilles will intercept this, determine what is the column name, which is updated, and the new value, put all this in the dirty map. And this dirty map is used at runtime to generate the exact update statement with the exact columns to be updated. And of course, all those update statements are put in a cache to be reused. Another interesting thing we discover is insert strategy. What is it? Suppose you are preparing this query to create a new contact. Okay? So you are putting all the possible columns in your prepare statement. But most of the columns are optional. So at runtime, you may bind null values, of course. The thing is that you are inserting null with SQL. And inserting nulls means deleting data, means creating tombstone, times 7 denormalization, times billions of contacts created. So we don't think it's a good idea to create so many tombstones for nothing, especially because it will take some place on your disk, and it will put a lot of pressure on your compression, of course. So the idea is to use a strategy, insert strategy, not null fields. How does it work? At runtime, when you are inserting data, Achilles will inspect your entity, just pick the columns which are not null, and generate, again, the appropriate statement for you. Put in a cache, of course. I was talking about byte array conversion to UUID or long. So here, with Achilles, you can bring your own codec. Okay? Here, with this annotation, you define your own codec class. And what you need to do is just to implement this interface. So at runtime, Achilles will perform encoding and decoding on the flight for you. Really easy. The last thing that we use a lot with Achilles is dynamic logging. When I created Achilles, I didn't want it to be a black box, something magical, and people don't know what is happening. So if you want to know what is happening behind the scene, you just need to turn on a logger. So Achilles will just print out all the statements and the bound values. And we use this feature a lot during the benchmark test to fix bugs. Okay? What is nice is it can be activated at runtime. You need not to recompile your code and redeploy. And it saves us hours of debugging. One interesting thing is you can also have query tracing by putting the trace log level. And that's it.
Well, we only have half an hour there. We cannot dive into many more things, but we'd like to highlight a few things that we've learned from that. Data modeling, as you may all know, is an essential part of the success or failure, and it better be right because we want success. migrating is also an important phase, and you have to understand that the double run strategy is kind of useful if you don't want to interrupt your production. And the timestamp trick is interesting for concurrent updates. We use this, and we are kind of happy with that. So, good thing to know. Data types between the SQL world and Cassandra is very different, and you have to take a lot of care to understand what this means in terms of size and capacity planning, and because, as you said, ints or UIDs can have an impact on your ring, and we may not have an upper ring with 17,000, I don't know, rings. It's a lot. Benchmark. Really benchmark, because things, as I said, that are not visible at a low scale become visible under load. And it will reveal things in your code, as in your data model. Of course, it's a team effort. So everyone on board has to be brought on board. It means that the marketing has to understand that you are ready or not. It's really something important, because usually devs teams and marketing does not live in the same room, but they have to be on board on that. And ops, of course, they have to be there, because they will be the guy that will challenge the design. They will be the guy that say, oh, we need this rings, we need this CPU, we need this space. And you have to understand that as a dev. And dev, of course, have the change. They cannot be rely on the flexibility of queries. They have to understand upfront what or how the query will be accessed, the data will be accessed. And that is all. Thank you everyone for attending. If you have questions, yeah, we'll be able to answer them.
Yes, questions.
After you know if your database was with Cassandra, what was the size difference in data? How big it was the Cassandra?
Well, we have already in Oracle we have like gigabytes or terabytes of data. So that means we are, for each node, there is a replication factor of 3. So we had to increase the ring, adding 5 nodes and maybe others later. And on each node, you have to be careful about the data you expect already from the migration. So it's like 800 gigs per node minimum. And you have to think that the user base is growing, so the data is growing as well. And there's compaction. So you have to think about Teradata on your nodes.
So roughly what was the proportion, the relative increase?
Well,
I
would say times 7.
Yeah.
Times 7. You denormalize 7 times.
And there's the denormalization.
We made as much optimization as we could with the byte array storage to save a lot of space. But yeah, there is no magic. You denormalize, you are using most disk space. It's a trade-off between disk space and latency. Yeah. We want low latency, we have more disk space. That's fine. Yes, we have compression. We activate it by default, fortunately, because the compression rate, with the compression on, you can gain, the gain is between ×2 to ×5. So yes, it is always on by default, and we don't care about CPU. We want to trade CPU for this space also. Yes.
One thing relevant to compression is that it uses CPU. So you have to, the CPU is also a limiting factor. You have to understand that we had all machines, and these machines are to be upgraded for that matter, because as the user will slow, there's more stress on Cassandra. So compression is another factor with compaction and GCs.
We're in the early stages of trying to migrate from SQL to Cassandra as well. And at the moment we use Liquibase, to manage our schema upgrades.
Yeah.
We don't really have an alternative that we can find in the Cassandra world. Is that something that you guys have dealt with at all?
In another project, we use Cassandra. We try to make like an automatic schema migrator. It's like you define in the code, you find a new a set of enter statement, and it will apply it, and it can be run back, because we save in the schema table the run back statement to go back to the previous state. But there is not, right now, there is nothing really industrial. I mean, it's handmade. And for the data migration process, well, it is, yeah, handmade. It's no automatic things. Because we believe that schema is something important in Cassandra. Defining the correct partition key and clustering column is really important for your read path. So we don't want it to be automated by a tool. We need to control it, really, and we need to give the script to the ops, because they will be responsible for production. Yes. Another question?
Yes?
This queue pattern you mentioned, DTL, did you run into a compaction, stuff like that?
Actually, we have think about tombstone from the start on this column family, because as you know, queue patterns creates wide rows, and at first we did that that way, but tombstones were really an issue. So we have to think again and go back to the drawing board, and then we thought about this idea of bucketing per date, because the data state compaction was not yet available in Cassandra. So we have to think this differently, and buckets were really a solution. And also, as the primary key is both the user ID and the bucket, the mount bucket, we know it's not a problem. Also, we use the GC grace period, and we set it to 0, because the tombstones are not compacted anyway. And this data is going to die anyway, because there's a TTL on that.
Okay, but when you use GC, like the tombstone 0, aren't you afraid of data?
Yeah, resurrecting things. Yes, we are aware. But it's like a timeline for modification dates. So we may run into corner cases where, yeah, okay, there's some columns popping out. But yes, we made a trade-off, and yes, okay, it's fine. It's not a critical business scenario. So it's fine sometimes 1 or 2 columns are just popping up. We don't care. We want to make the compaction very fast, and we want to remove all the tombstone things.
Yes?
What operations talk about Cassandra?
Sorry, what?
The operation team, what do they think? Do they have any issue migrating?
Yes, there's still some issue on the ops side. Actually, the most difficult thing is tuning Cassandra. Because, as I said earlier, relational database, they have kick-ass DBase. They know the technology very well because it has been existing for a long time. So it's very mature on that regard. In Cassandra, we have to learn things. And even reading the doc doesn't suffice. You have to fill things, etc. So it's kind of something that we are still working on at Libon.
They need to gain experience. They have already experience with events, because events are stored in Cassandra. But now we are bringing something new with new design, with aggressive, data modeling to avoid tombstone. So the ops need to be aware of this, because they are managing the platform at the end of the day. So yes, and we try to educate them to understand the way how Cassandra is working underneath.
There's a question there.
The data seems like a graph. Did you do any experiments with Titan?
Right now, not. We don't have any scenario yet for matching with using graph. It may come in the future, but right now not. Sorry, I think we people.
We are almost
we are finished. You can ask questions later if you can.